We're going to talk about laws of logic. Okay. And reminder, tomorrow we do have a quiz. It'll be covering sections 2.1 to 2.5. I think very little is on 2.3. I think maybe I didn't really even put it on there, but it's easier to say sections 2.1 to 2.5 rather than 2.1 to 2, 2.4 to 5. So, laws of detachment, law of syllogism. A couple terms that you probably haven't heard before. What they are is a sequence of ideas. If you have the ideas that fit together right, then you can make a valid conclusion. Valid means, does that conclusion follow the correct thinking process? Okay? So there's two thinking processes that are acceptable in logic. So let's first talk about the difference between inductive reasoning and deductive reasoning. Probably first page of this chapter. What was inductive reasoning? Is that where it was? Inductive reasoning. What's that reasoning based upon? Read the definition there. So you're looking at specific cases to see what a pattern is. So inductive reasoning was looking for a pattern and then describing it, kind of informal. Deductive reasoning that we're on in section 3 is very much structured. It's not informal at all. Deductive reasoning is the process of using logic to draw conclusions from given facts, definitions, and properties. Not just looking at examples. Facts are not the same as examples. A fact would be, let's see, a fact would be the second year of high school is your sophomore year. An example would be, Canaan is a sophomore. That's an example of a sophomore. The definition is that a sophomore is the second year of high school. It's the difference between a fact and an example. Deductive reasoning, inductive reasoning. So we are going to use deductive reasoning for the majority of our class. We're going to base a lot of what we do on definitions. That's why you need to know what they are. Laws of logic, that's what we're talking about right now. Theorems, postulates, we'll keep adding to that list as we go through. Okay? So this is the law of logic called law of detachment. Okay? And it says if we have, what's this mean when it's P arrow Q? Like an if-then. Okay, so if we have an if-then that is true, like you couldn't make a counterexample to it, an if-then that is true and the hypothesis is true, then logically the conclusion has to be true. Now how that fits in what we discussed a previous day is, remember this chart right here? Okay. Have you seen it before? Maybe you don't remember it? Okay. The law of detachment really follows this first row in this logic chart. Because let's read through it. The if-then has to be true. Well, if-thens are true 3 different times. But then it also says P, the hypothesis, also has to be true. So for the hypothesis to be true and the if-then to be true, it's this first line in the chart that we would be talking about. So if the if-then's true, the hypothesis is true, the conclusion has to be true. Let's look at any other combination. Here, if the hypothesis is true, false, that doesn't fit. True, but false hypothesis, that doesn't fit either. So the law of detachment really is talking about this first line in the truth values. So we're going to be looking at an if-then that's true, and then see if we also know the hypothesis is true. If so, we can make a valid conclusion that the hypothesis of the if-then has to be true. You're going to think it's probably just, common sense. But it's just referred to as the law of logic. We just want to make sure that we're doing it right. Law of detachment. So it's a given fact. If the Seward pool is open, then it is a warm summer day. Then another fact, the Seward pool is open. Now notice how that is stating the hypothesis. So that's like saying that's true. So we've got an if-then that's true and the hypothesis that is true. So is it correct? Is it valid to say it is a warm summer day? Yes, that one follows the law of detachment. Now, how it would be incorrect is if the Seward pool is open, then it is a warm summer day. If another beginning fact I said was it is a warm summer day, and then the pool is open, that would not follow logic correctly. Because up here, I need the hypothesis is true, not the conclusion. So you can't switch the order. Kind of like you can't switch it to a converse and still be true. You have to watch the order. Okay, in the World Series, if a team wins 4 games, then the team wins the series. The Red Sox won 4 games in the 2004 World Series. Is it correct that the Red Sox won the 2004 World Series? Kind of wordy, you have to read a little bit. So if a team wins 4 games, Red Sox did. So the team wins 4 series, or wins the series, yes. That one does follow the laws of detachment. If school is dismissed early, then Jenny needs a ride home from school. Jenny needs a ride home from school. Is it correct that school is dismissed early? Good. Some of you are saying no. This one doesn't fit right. What's the P? What's the Q? School is dismissed early is the hypothesis. Notice I put Jenny needs a ride home. I put the hypothesis down here. That was the wrong place for it. So that one was backwards from what the pattern was. And if you think about it, okay, just because Jenny needs a ride home doesn't mean school is dismissed early. Going in the reverse doesn't work. She could be just sick or something like that. All right, marker board. I want you to tell me yes or no on this. Force you to commit to an answer. So as you read through, think about what's the P and the Q of the if-then. Because also in that hypothesis, the beginning part, I need to know that the hypothesis is stated true. And if it's not that, then we don't have the right information to make a conclusion. Commit to a valid or not valid, a yes or no on that one. These 3 dots mean therefore, or a correct conclusion would be Q. Read through the if-then and figure out what the P and the Q would be. Make sure they're stating P as true. And the valid conclusion is that the Q part would have to be true. Okay, valid or not? Show me. We have a lot of no's, and that is correct. What was the P part? Well, the base and the height being 5 and 12. The area is 30. So then I should have said I have a triangle with 5 and 12 as the base and height, but that's not what was there. These 2 are backwards. Try this one. Again, think about the if then. What's the P, what's the Q? And did I give you another correct follow-up fact? Make the conclusion. Valid or not? Yes or no? Two more show me's? Okay, that one is valid. There's another thinking or law of logic that works. It's called law of syllogism. Kind of a fun little word, syllogism. Syllogism reminds me of the transitive property, but it's not the transitive property of equality or congruence. It just kind of reminds me of it. It's kind of like a transitive with if-thens. So we're going to have two if-thens that we need to have for the beginning, and then a conclusion can be made from them. Well, if your two if-thens have to be true, and the conclusion of one of them has to be the hypothesis of the other. That kind of linking together is what reminds me of the transitive. So what we can get from the law of syllogism is another if-then that would be true. Many of you, or are you familiar with the books? Like if you give a mouse a muffin, if you give a mouse a cookie, a moose a muffin, a pig a pancake, those things, those books? Okay, and if you're not familiar with that, it's kind of a series of things. Like if you give a mouse a cookie, then he's going to need a glass of milk. If the mouse needs a glass of milk, then he needs a napkin. If he needs a napkin, then he needs a trash can. So that series of things, basically, if you give a mouse a cookie, he's going to need a trash can. You can get from the first to the last in that sequence of things. That's what's going on. That's a good example of syllogism. So on law of syllogism, the kind of things that you'll be telling me, is that valid or not? Is it a if-then that is created correctly from your starting two if-thens? So let's try and figure out what's the P and what's the Q. Okay, the P and the Q and the R, I guess we've got three parts. I always search for the Q first. The Q is the repeated part. So look for the conclusion of one if-then and the hypothesis of another if-then. We're looking for those to be the same. If figure's a kite, then it's a quadrilateral. If the figure's a quadrilateral, then it's a polygon. Okay, see the quadrilateral part repeating? It's the then part in one sentence, it's the if part in the other. So that's my Q part, according to the pattern. So looking at the notes, wouldn't kite be P, because I called one sentence if P then Q, and the other one if Q then R, so R is being a polygon. With me? Okay, so what's this valid conclusion supposed to be made out of? What's the if then? The which ones? Not Q and R, look again. The conclusion part is supposed to be P and R. So is this, if P, then R? So notice how that fits what was up there. If P, then R, so that is a valid conclusion or statement by law of syllogism. I'm going to put some notes on the board here. Syllogism. And if it makes more sense having the squares and the circles and that I put on your notes, I thought some of you might be shape people. Syllogism. Okay, you need if P, then Q, and if Q, then R to be true. So therefore, you come up with if P, then R is true. All right, we're going to look for the pattern now. Identifying the Q is kind of a key for me. All right, your true facts. If a number is divisible by 2, then it is even. If a number is even, then it is an integer. We analyze that to figure out what's the Q, what's the P, what's the R. And then, once you have those identified, is the concluding conjecture made correctly. Have if P then R. What's the Q idea? There?
Oh.
All right. It was the conclusion there, it was the hypothesis here, that's our key. All right, so P would be the if part here, divisible by 2. R would be, it's an integer. So is this conjecture if P then R? No, it isn't. Number is an integer. That's what we labeled, that's the R in the pattern. Divisible by 2 was the P. It's backwards, so it's not valid. Give me a thumbs up or down, does that make sense? Got kind of some weird looks, but okay. All right, so let's have you do the next one. Put it on your marker board so I can see. Why don't we have you discuss this one with your partner, I guess? Discuss with your partner. Valid or not?
Oh man, one of the dogs.
You should be able to read that.
Does that say in taco salad? Oh, there. What are you doing this week, Dad? Is it heat cell playing or is basketball season over? I haven't watched basketball. So.
Okay, did you agree? I
Yeah.
think some of you are agreeing. So valid or not?
I said it was that.
You said it is valid? Not valid?
Unless it was shaved. So.
Well, does it fit the pattern of syllogism? What did you pick out? Was there a Q part? An if in one sentence and that is the then in the other sentence? I think there is. There's a if in one sentence that is in the then on the other sentence. The sentences are switched from the first two examples, but see the if part being a mammal, the then part being a mammal, that's my cue. That's the connecting idea. So now one sentence, the one that has the then part has the cue, it starts with what I'm going to call P. So P is animal is a dog. The other sentence ends with what I'm going to call R. So R is it has hair. So I'm supposed to figure out, is the last if then correct? P then, is this the P? Is this the R? An animal is a dog, yeah. Then it has hair, yes. It's in the right order, valid. Any groups get that right? Not too many. I switched the first two sentences on you, but it still follows the pattern as far as how you can analyze it. Okay, let's go to another example. You know, on this one, I'm not asking you, does it follow? I'm asking you to make the correct conclusion. So I'm giving you two facts. If a polygon is a triangle, then it has three sides. If a polygon has three sides, then it's not a quadrilateral. That to me sounds like two if-thens. Is it set up in a way that you could connect it by syllogism and make a conclusion? Your conclusion is going to be another if-then written correctly. Discuss with your partner, see if you agree.
a quadrilateral has four sides? Come on. Come on. These are different. My things, like dead
Okay,
things.
that one should have been, if a polygon is a triangle, then it is not a quadrilateral. Groups get it right? Okay, making it up yourself was a little bit easier. Okay, how about this one? I'm giving you three things that you could use. If a polygon is a triangle, then it has three sides. If a polygon has three sides, then it's not a quadrilateral. Polygon P is a triangle. There could be more than one thing you can come up with. You might first work on, is there a syllogism, if then, that you can make? Okay, discuss.
You simplify things so quicker, and you got in more depth. Let's see, like a polygon P.
Okay, conclusion. Let's see, the bottom one's probably the one you came up with. If a polygon is a triangle, then it is not a quadrilateral. You got that one? Okay, that's the one that's done by syllogism. Now, if we go back to detachment, we really could come up with a couple things based on that. What I would be doing for this first one, let me scribble out this middle one for a little bit. Okay, thinking detachment, I have an if-then, and I have a fact that relates to the hypothesis. So using that, I could come up with the fact that polygon P has three sides. See how that's put together? If the polygon's a triangle, then it has three sides. Polygon P is a triangle, so polygon P has three sides. Now, if you would use that one, change my scribbles. Okay. Now, if I use, let's see, polygon P has three sides, and this if-then, if a polygon has three sides, then it's not a quadrilateral. Can you see how I can say polygon P is not a quadrilateral? That follows also. All right, let's see if I have another example or not. The sum of the measures of two, if the sum of the measures of two angles is 180, then the angles are supplementary. If two angles are supplementary, then they're not angles of a triangle. Measure of angle A plus measure of angle B is 180. See what all you can come up with. You're just forcing yourself to think about how you think, how you need to think. That's what's kind of confusing. Something clicked?
A little bit.
Okay.
I think so. I doubt it, but
I'd say the syllogism one you can probably come up with. Supplementary, then they're not angles of a triangle. See the supplementary thing? That idea connects you to call them the Q, because the Q part is the part that repeats. What was the conclusion in one, or the then part of one, and the if of the other, so I call that the Q, or the Q part.
Just so I like. I better be right, 'cause I'm going off the bill heat. Your Packers fan.
Give me an if-then. What's the law of syllogism come up with? Who feels that they can do this one? Law of syllogism. Not worried about me calling on you, just you think that you got the if-then? I got 4 people that think they got the if-then.
Let's see if I'm right.
You want to see if it's right, and then you'll go, Riley?
Yeah.
The sum of the measures of two angles is 180 degrees, and they are not angles of a triangle.
Correct. Okay, I'll show it. I've got some more at the bottom, but the syllogism, if the sum of the measures of the two angles is 180, then they are not angles of the triangle. So notice, think about that book. If you give the cookie, then they need milk. If you give milk, then they need a napkin, okay? The angles are adding up to 180, they're supplements. If they're supplements, then they're not angles of the triangle. So wouldn't we go completely from them adding up to 180 to not be angles of a triangle? But you really don't have to think whether the statement's true or false or not, just are the words following the correct kind of pattern? Now there are a couple detachment things you could do, because I told you A and B do add up to 180. So you could come up with something from the first if-then and the second if-then. I'm not worried as much about that. And how are syllogism and detachment going to relate to what we are doing? Actually, yesterday you kind of did the law of syllogism, just not written with the words if and then. But let's go back to just a real simple algebra problem that you might have done yesterday. If 3x plus 1 equals 19, then doesn't 3x equal 18? And if, well, maybe I should leave that there. And then if 3x equals 18, then x equals 6. Trying to show you this is kind of like a if-then, and then another if-then. So basically we would say if 3x plus 1 equals 19, then x equals 6. You're putting ideas together into a sequence. That's what proof involves. You probably did it without thinking about it, but that is the thinking that's going on. All right, what you have to do on that part, that's the heavy part for today, to try and figure out law of syllogism, law of detachment. You're telling whether it's a valid reasoning or not, and then I think there's a couple where you come up with the conclusion. All right, the easier lesson is the 2, 6, and 7, the theorems. So why don't you go touch 2 walls, and then we'll do that lesson. Okay, so get up out of your seat for a little bit.
And that's what I love.
Touch 2 walls, and we'll go to the other lesson. All right, touch, not hit, not. All right, so on the 2, 6, and 2, 7, we're going to spend multiple days on this. The part that we're going to do today is we're going to take a look at each of the theorems and see what they're about. So again, what we are doing is deductive reasoning. We just talked about that in lesson 2 and 3. Deductive reasoning uses logic, facts, definitions, properties to make our thinking process. A theorem is any statement that you can prove as true. And that's why we're starting to talk about how you prove things and what the logic in proving is, so that we can prove theorems. Once you've proven a theorem, you can use it down the road in future ideas or later proofs. So here's the first theorem that you should be able to find. 261, I think is the number there. Okay, this one has a title. It's called the linear pair theorem. If you learn it by its title, then you don't have to say the whole sentence all the time, but you have to know what the sentence is. So you either have a choice of learning the whole sentence and writing it out all the time, or learning it by its name. All right, what it says is, if two angles form a linear pair, then they are supplementary. Okay, what's the hypothesis? Two angles form a linear pair. So you can either put that in a picture form if you want to, or you can just write it in words. Two angles form a linear pair. What's the conclusion? They are supplementary. Let's do some thinking about why that works out. Not really proving it, but do you understand why that works out? What's a linear pair? What's the definition? How many know? Linear pair. If you don't, grab your chapter 1 notes. Here's where you've got to know things from last chapter. Linear pair, is that? Oh, think of the wrong thing? Okay, think of a different thing. Kanan? That sounds like supplementary definition. Linear pair.
Two angles that are adjacent and they share like a line.
Okay, the line is where the linear pair comes from. Okay, adjacent, put together. Okay, so if I drew a picture of that, if I had a picture in a diagram that looked like this, there's a linear pair of angles. Now this theorem says that if we've got that situation, then they're supplementary. What's that mean? Not that they form a line, that's not what supplementary means. Going back to what Tanan said, he gave me the definition of supplementary. Say it again. Okay, so we're saying the angles in this picture, like this one and this one, will always add up to 180. Looking at the picture, does that make sense? 180 degrees, wouldn't that be a straight angle? And there's a straight angle in that picture. Okay. So we will eventually prove this theorem, but right now we're just trying to make sense out of it. So let's do an example. I think I've created one example for each theorem. If that's enough, we'll go with that. So find the value of x and the measure of each angle. Is there a linear pair of angles? Yes. The theorem we're working on says then they are supplementary. We just discussed what that would mean. How would you figure x?
Picture.
That helps you
Nice
learn.
picture.
What is x? And then to check it out, we'll find each angle. Gotta make a connection between our words and our calculations. What is, they are supplementary. Okay, so those two add up to equal 28.
Yes, sore throat. You might put the cap on that marker. That could be why it dries out faster.
Okay, did you end up then, when you checked it with the angle measures, did you get two angles that add up to 180? answers, I come up with x being 27. So then the angles were 54 and 126. Okay, thumbs up or down? Some of you aren't giving me a signal. All right, the ones I saw were all up. So we can make sense out of that theorem. Next theorem. Next theorem is called the congruent supplements theorem. And it has more than one way it could be used. So if two angles are supplementary to the same angle or to two congruent angles, that's a second way it could be used, then the two angles are congruent. So what's our hypothesis? Well, what's the hypothesis? Angle or to two congruent angles. So not the word if, but so your hypothesis, two angles are supplementary to the same angle is the main way, or they could be supplementary to the same angle. Conclusion? Two angles are. So let's try and make sense out of this one. I'm going to set up not the parenthesis part to start with. Okay, two angles supplementary to the same angle. I just need to know their measures. I don't really need to draw a picture, do I? The supplements, it doesn't matter what they look like, just what they add up to be. Okay, so let's go measure of angle 1, measure of angle 2, measure of angle, I think I need 3. Okay, two angles supplementary to the same angle. So let's make angle 1 supplementary, 100 degrees, and angle 2 would have to be, if they're supplements, 80 degrees. I made these two supplementary. Now let's make angle 3 also supplementary to angle 2. Let's make those supplementary. So what would angle 3 have to be? 100. So have I set up two angles supplementary to the same angle? Which are the two angles? 1 and 3, and the angle they're both supplementary to is angle 2. This theorem said the two angles are congruent. So we ended up with angle 1 and angle 3 being congruent. Does that make sense? So if we had angle 2 as 40 degrees, angle 1 is 140, angle 3 is 140. Angle 1 and 3 end up the same. So if you know that theorem, you maybe don't have to do the calculating. Now how's the parenthesis part go? Or to two congruent angles? Well, let's say, we have to change this a little bit. Those two are supplementary. Let's make angle 3 the same as angle 2. And then we'll say angle 4 is a supplement to angle 3. So 1's a supplement to 2, 4 is a supplement to 3, but 2 and 3 are the same. They are congruent angles. Still, can you see where angle 4 ends up the same as angle 1? All right, let's try the example. Hopefully I didn't use the very same numbers. Okay, so here's your situation. the answer to part A. Part B, you should be able to do quickly, not all the thinking that I did on the thinking through the theorem. Molly, which two angles will be congruent? Correct. So if angle 1's 52 degrees, angle 3 would be, Megan? 52 degrees. Did you have to find angle 2? Not really, if you know the theorem. Does that make sense? Okay, right angle congruence theorem. This one's really easy. All right angles are congruent. Now to figure out the hypothesis and conclusion, I wrote what I thought a conditional, an if-then form would be. If there are two right angles, you could have more, but I just went with two. If there are two right angles, then they are congruent. So what's the hypothesis? What do you have to do this theorem? You have to have two congruent angles, or two, not congruent, sorry, two right angles. At least two right angles. What's the conclusion? They're congruent. Why does this work? Convince me. Tell me about a right angle.
It's 90 degrees.
Okay? So if I have angle 1 that's 90 degrees and angle 2 that's 90 degrees, how does that make them congruent? What's congruent mean? And for angles, they have the same degree measure, so that's what we've got. So this one doesn't take a lot of hard thinking. Make sense? Okay, so what can we come up with for my example? What can you conclude? And how about write it in correct math symbols? Don't just be vague. Tell me what you're talking about. We have a symbol for congruent. What's our conclusion? Don't go in 90. The theorem says they are congruent. That's it. What says that they're 90 degrees would be the definition of a right angle. So that's a different thing. Okay? So just simply angle ABC is congruent to angle RST. All right, that one will be easy to remember. Called the right angle congruence theorem. Okay, the last one in this section is just like that congruence supplements theorem that we did before the right angle one, but it's complements. They're complementary instead of supplementary, but it's the same relationship. So if two angles are complementary to the same angle or to two congruent angles, then the two angles are congruent. So hypothesis, you need to have two angles complementary to the same angle, or you need to have two angles complementary to congruent angles. Conclusion, those two angles are congruent to each other. I think I'll just go directly to the example on this one because I kind of explained this with the previous theorem. That's your hypothesis and conclusion. Okay, so here's your example to think through. of those are the same angle, so I did the complements to angles that are congruent. Okay, didn't mix it up on this one a little bit? Let's go back to the theorem. If two angles are complementary on the example, I didn't make them complementary to the same angle. I made them complementary to two congruent angles. So we have to figure out which angles are complementary to which angles that are already congruent. Okay, so let's take a look at it in that way. Okay, so here I'm giving you two angles that are already congruent. So these two are already congruent. B is a complement to A, E is a complement to D. B and A are the two angles that are complementary to congruent angles. So the conclusion was that those two angles, B and E, will be congruent. In the end, I didn't give you angle B or E, I gave you A. To mix it up a little bit. So if A is 52 degrees, what's angle E? Well, what's B? Complementary, they add up to 90, so 38. So E has to be 38 also. So it was 38 degrees there. Yes. Okay, which ones equal each other? A and D? Okay. So if A is 52, D is 52. But the question I asked you, what's E? Instead of what's D. So how did I get E? D and E are complementary. Does that make sense? Can you look a little closer? Depends which angle. If I would have given you what angle B is, like 100, no, I can't go 100, 70 degrees, then angle E would be 70. It would be the same. But because of which one I gave you, it wasn't the very same measurement. So I kind of mixed up the example a little bit on that one. Theorem 271. I think there's 3 theorems. You have to flip a couple pages. 371 in your notes. Congruent or common segments theorem. Yes.
This is asked about what we're doing.
Yeah, those 3 theorems.
Is that it for today?
Yeah, we're skipping some of the other parts. We'll come back to those in the next 2 days. We're just going through the theorems today. This one is a certain way that the picture has to be. So your hypothesis, you have to have the segment in this order. So given collinear points A, B, C, and D arranged as shown. If AB is congruent to CD, some of you are just sitting, you need to be writing down your hypothesis. The hypothesis would be this diagram. A, B, C, D arranged in that order. If AB is congruent to CD, then AC's length, AC's length is going to be the same as BD's length. How do those lengths end up the same? Let's do a little thinking on this one. Let's say AB is 10. So then, since we want AB and CD to be the same, that one's also 10. To get AC, don't I have to add BC's length on to AB? So let's put a 27 there. So if that middle section's 27, how long is AC? 37. How long is BD? 37. Notice how they ended up to be the same? Why do they end up being the same? Well, it's kind of like AB equals CD, let's just put the name of it. Let's add the length of BC to each side. AB and BC would give you the length of AC. CD and BC would be the length of segment BD. It's like the addition property of equality. You're adding that same segment length to each starting segment. You could do the subtraction, I think your book maybe sets it up in a subtraction instead of an addition. Let's see what my example is. I want you to figure out AC and BD's lengths. It might help to draw the picture and put the numbers on there. The page you might want to draw the picture and put the numbers on the diagram and see on the example. At the bottom of the page. AB is 9, CD is also 9. BC is 19. How long is AC? How long is BD? Michael, what are you coming up with?
I have the measurement of angles for segment AC to be 28, and same with BD.
Okay, so they were both 28. So you're adding that middle segment onto each one of them, and they end up with the same total. That's called the common segments theorem, because you're adding a common segment length to it. Vertical angle theorem we use a lot. Okay, vertical angle theorem. What do vertical angles look like? Because this would be, if we have vertical angles, then they are congruent. So what would a picture look like? I know the hypothesis is you need two vertical angles. What do they look like? Vertical angles, last chapter. Last chapter, vertical angles. Okay, some of you are remembering now. An X, vertical angles are across from each other. So like angle 1 and 2, or the top one and the bottom one. So if that's your setup, you've got vertical angles, this lets you conclude they are congruent. So angle 1's degree measure is going to be the very same as angle 2's degree measure. Let's see if that really works out. And let's start with this one being 50 degrees. What's this bottom angle? 130 because of that linear pair theorem that we had just a little while ago. Okay, what's angle 2? In linear pairs, that would be supplements, 50. Notice angle 1 and angle 2 end up to be both the same. We can prove or think through this one using the first theorem we talked about today. Example, find the value of x and the measure of each angle. Do we have vertical angles? Yeah, they're across from each other, formed by two lines. So the theorem said vertical angles are congruent. Think what that means. Okay, set up your equation then. Figure out what x is. Them to be congruent. You want their measures to equal. like it's 180 degrees? No. The theorem that we're looking at right now says vertical angles are congruent. The conclusion would be that angles are congruent. So those angles are supposed to be the same. So 7x minus 28 has to equal 5x plus 4. No 180 in there. It's the same. So you need 7x minus 28 equal 5x plus 4. Algebra to solve. Alright, let's get those equal to each other. Solving it, x was 16. And what were the angles when we substituted back in? 84, which one? We use that theorem a lot because many of our diagrams will have vertical angles in there somewhere. All right, and the very last theorem. Are you ready to get rid of that example? 32 divided by 3. Okay, and the last one doesn't have a name to it. So your book just refers to this one as Theorem 273. Or else, see this little abbreviated thing in the end? They will use that instead of the name. And that's just an abbreviation in symbols and short notation of what this sentence says. An arrow means an if-then. If there are congruent angles that are supplementary, then they are right angles. The hypothesis. Two congruent angles are supplementary. So the angles have to be congruent and they have to be supplementary. Then each angle is a right angle. Let's see if that makes sense. The angles are congruent, that means you have to have the same measure. And they are supplementary. They have to add to 180. So if they're the same and they add up to 180, how big is each one? 90 degrees for each one. So would that lead you to the conclusion that they are each a right angle? 90-degree angles are right angles? That one make sense? All right, what's the example that I have for that one? If angle A and angle B are supplementary and congruent, what can you conclude about them according to Theorem 273? What can you conclude about the two angles that are congruent and supplementary?
You
Tristan?
know, measure and degrees and the sum of them.
What's it say in the end of that theorem?
The right angle, the proper angle.
Okay, so you would say angle A and angle B
Alright.
are right angles. Can you come up with the other ideas? Yes, but this theorem doesn't tell you that. You'd have to know the definition of right angle to come up with what you were saying. So you're simply saying that angle A and B are right angles.
So would it be wrong if we said A and B are
That would be wrong based on the theorem. Because what you're using is the theorem and then you're using the definition of what a right angle is to come up with the 90 degrees. That's two thoughts instead of just this one. Okay? All right. The lesson then, the assignment has two parts to it because we did a little bit on that syllogism and detachment. Actually, 3 pages back, because we did three things. But we're going back to those same two sections to do different things tomorrow. Okay, so the 91 is the syllogism and detachment. These are the section 6 theorems. And then the section 7 theorems. of those are like work out, like the examples that I was having you do up here. Our quiz, I'll put a reminder about. Our quiz tomorrow is over 2:1 to 2:5. And you can look over 1 through 14, 17, and 18 on this page as a review. And you do have about 10 minutes to start on. You might want to go to that page 91, the syllogism and detachment, just in case you have questions related to that. I think the other section will probably be easier for you, those other pages.